Welcome to this instructional video on smoothing, looking at a 4-point moving average with centering, or what we call 4-point moving average centered. Once again, this is looking at trying to eliminate the fluctuation and variation within a set of data so we can establish trends on a scatter plot. So let's look at our 4-point moving average centered. Again, we have a set of data looking at the number of births per month over a calendar year at a particular hospital. We've looked at this example before. So in January there's 10 births, February 12 births, and so forth, down to December 15 births. Here's our data graphed. Again, we've used a time scale down the bottom. Time code, 1 for January, 2 for February, 3 for March, etc. Okay. We can of course use our TI Inspire to graph this. Here's our months and births. We can go to a graph, click on that, show our births on the y-axis, our months on the x-axis, and there we go. There's our data scattered all over the place with great variations, high values of 22, low values of 5. We could of course do a linear regression, not that we need to do one for this particular task, but we can insert linear regression, and there we have it. So there's a fair bit of variation from our trend line. I'll just remove that because we don't particularly need that for what we're about to do. Okay, that's good. Okay, let's go back. We want to look now at a 4-point moving average centered smoothing. So look, again, we take 1, 2, 3, 4 points, and we find the average value of 10, 12, 6, and 5 added together divided by 4 gives me 8.25. Now, when we've got 4 points, we don't have an actual average that's against a particular month. The average between 4 is kind of stuck between 2 and 3, so it doesn't actually line up with February, nor does it line up with March. It's kind of stuck in between. And this is the added complication with an even number of point moving averages. Let's move down to our next set of 4, 12, 6, 5, and 22. Add them together, divide by 4, we get 11.25. And again, that average is stuck between March and April, neither March nor April, but rather in the middle. We continue this process on all the way down till we get to our last bit of information in December. Okay, so you can see with the 4-point moving average, we lose data from the first 2 points and also the last 2 points, as we did with our other moving average smoothing techniques. So what we do is we take the average of the January, February, March, April, which was 8.25, and we average that against the average of the Feb, March, April, May. So our first two 4-point moving averages, we average the average of those two. Sounds a bit of a mouthful, but we average the average. We do this so that this average is now centered against a particular month. When we come to plotting this, these will be represented by time codes of 1, 2, 3, 4, and 5, etc., down to 12. And we need to have a value that is centered against a time code, in this case, March being number 3. We can't plot these 4-point moving averages against a midway point. It has to be averaged or centered against March. So we then center the next two averages against April, the next two against May, June, July, August, September, October. Okay, and there's our points, our 4-point moving average and our smooth value after centering. Let's try and do this on our CAS calculator. So we'll do first of all a 4-point moving average, and we'll take that back up to the top. So our first point, well, really should be between 2 and 3, but we can't do that on an Excel spreadsheet, so I'll go to point 3. Okay, so that's going to be equal the sum of the first 4 points divided by 4. Okay, so that 8.25 is the average of the first 4 points. Now, normally, again, it would be between 3 and 4, but we're going to put it here for now because we've got to choose one or the other. And I can follow that all the way down to 11. Okay, so we've done that. We've worked out all our 4-point moving averages. And now what I want to try and do is center this data. So if I center, remembering this really should be at 2.5, and this should be at 3.5, but we can't show that on an Excel spreadsheet, or rather on a TI Inspire. So this is going to be the average of these two, sum of these two divided by 2. Comes out to 9.75, and it's centered against timecode 3. Let's go back to our data. 9.75 centered against timecode 123, so we've done it right. Let's continue on with our calculator, and we're going to drag that value down. Went too far. We don't actually want that or that. Okay, so the last point was 5.25 centered against number 11. Let's have a look. Have we gone too far with that one? I may well have. 9.5 centered against number 10. Let's go back. 9.5 centered against number 10. That's the one. We don't need that point. Right, so we've got our data. We've got our 4-point moving average, and then we've centered them. This one is the average of these two, which really were 2.5 and 3.5 on the time code. I centered them against 3. This one is moving average centered against 11.25 and 12.75. It's centered against time code 4. So I have all our data. We can now have a look at our graphs. We're going to add to this one, add a Y category, and I want to look at the centered data. So this is the centered data when we smooth it. And again, we've taken a lot of those variations out, which is exactly what we needed. Okay, let's click on this, and we will go just the centered data. We can now add a line of best fit through regression. We'll use the form y equals a plus bx, and there's our line. So it says y, the centered value of births, is equal to 13.631. Take away 0.311012 times the time code for the month. Let's now have a look and see how we go with our graph. Okay, minus 0.3108, minus 0.311, slight variation, rounding error. Plus 13.632, plus 13.631, slight variation, not much at all. So there you have it. That's using a centered technique. Takes a little bit more focus. There's an extra step where you have to take your 4-point moving average and center it against one of the time codes for the month. But it works well, and again, it's being used to compare trends whereby we can actually center. And again, you can see here clearly this is a lot more centered, if I go back to this line of best fit, than is the large variation or fluctuation within the original data. Thank you.